Now we're going to look at the standard algorithm for multiplication. So when I do the standard algorithm, I'm going to set it up vertically, and whichever number is longer, meaning more digits, I am going to list that first. So for 9 times 67, I'm going to list the 67 first, and then below that list the 9. And then I'm going to start by doing 9 times 7. So 9 times 7 is 63, right? And what I'm essentially doing is I'm going to do 9 times 7, and then later I'm going to do 9 times the 6 in the tens place. So I'm doing the same expansion that I did with like partial products and lattice method, but I'm doing that part in my head, right? So 9 times 7 is 63. What I would have done with partial products is I would have written that down, the 63, and then I would have done the next multiplication, right? And then once I'm done with all the multiplication steps, we add it all up and do our regrouping, right? What we're doing with the standard algorithm is we're combining those steps. So it can be a little challenging at first, but it's actually more efficient. Instead of doing all the multiplication and then doing our addition and regrouping, we're going to do our addition and regrouping along the way, right? So when I say 7 times 9 is 63, what I'm going to do is I'm going to say, well, that's 6 in the tens place. I'm going to regroup that over here. And then that's 3 left over there in ones place. So 7 times 9 or 9 times 7 is 63. Regroup the 6. Then I'm going to go ahead and do the next multiplication. So the next multiplication is 9 times 6, which is 54. But I'm going to go ahead and instead of writing down 54, I'm going to go ahead and add to that the regrouped 6. So 54 plus 6 is 60. And so I would write a 0. Normally I'd regroup that 6, but there's not anything else to write that in. There's not another place value digit here. So I'm just going to go ahead and write those digits down. So it's a nice efficient method. So if I look at the next one, 4 times 583, I'm going to write the 583 first since it's the longer number. And then I'm going to write the 4. So essentially what I'm going to do is I'm going to multiply the 4 times every digit in 583. I'm going to do 4 times 3, 4 times 8, and 4 times 5. So 4 times 3 is 12. Instead of writing that down and adding it later, I'm going to go ahead and add it now. So I'm going to say 12 is really, I'm going to have one group of 10 and 2 left over. And so then I'm going to do my next multiplication, 4 times 8. So 4 times 8 is 32, but then I'm going to go ahead and do my addition. So add that one that I regrouped and I get 33. So that means I'm going to write a 3 and I'm going to regroup a 3. And then I'm going to do now 4 times 5 is my last multiplication. So 4 times 5 is 20, but instead of writing 20 down, I'm going to go ahead and add the 3 that I regrouped. So I get 23. And there's no other digit there in the next place value for me to regroup the 2, so I just go ahead and write that down. It's essentially saying 2 plus 0 is 2. And so my answer here is 2,332. So let's do 39 times 45. We did that one with the other two methods earlier. So since they're both 2 digits, it actually doesn't matter what order we list these in. So I've just gone ahead and listed the 39 first, but it wouldn't matter. You could have listed 45 first. It would work out differently, but give you the same answer and end. So this one's a little bit more complicated because I'm multiplying by more than one digit here in my second number. But again, I'm just expanding this, right? So what I would have done with partial products is I would have expanded this and said this is really 40 plus 5. I would have taken 5 times everything in the other number, and then also 4 times everything in the other number. So I'm going to do the same thing here. I'm just going to do it a piece at a time, and I'm going to start with the ones place. I'm going to start with the 5. So I'm just going to start by doing 5 times 9, and then 5 times 3. So 5 times 9 is 45, but instead of writing that and adding later, I'm going to go ahead and do my regrouping and addition steps. So 45 I would write as 4 groups of 10 regrouped in the next place value, and then 5 left over. And then I'm going to go ahead and do the next multiplication with 5. 5 times 3 is 15, but then I'll go ahead and do the addition, add 4 to that, and that's going to give me 19. And there's no place to regroup the 1, so I'll go ahead and I'll write that down. So I'm going to go ahead and color code this. You would not have to, but it might make it a little bit easier to see. So now that I've taken the 5 times both digits in my first number, now I need to move on to the 4. And so I'm going to go ahead and multiply that 4 times both the 9 and times the 3. So 4 times 9, if I start with that one, 4 times 9 is 36. However, that 4 is technically in the tens place, right? So that's really 40 times 9, which would be 360. So we can go ahead and do that multiplication. What we would typically do, though, is we would just say, well, it's really whatever 4 times 9 is, and then add a 0 to it, right? So we're just going to go ahead and put a 0 placeholder and then ignore the fact that the 4 is in the tens place after that. So I'm going to say, okay, let's put a 0 placeholder. 4 times 9 is 36. So I'm going to write a 6, and then I'm going to regroup a 3. Now, I will tell you, this is clear because I've color coded, but this can get really tricky when you're doing this all in pencil or same color pen. So I've got this 4 that I regrouped earlier, and now I've got this 3. And I don't want to get confused between what I'm doing on this step and what I'm doing on the last step. So typically, if you're not color coding, typically what we would do is we would either cross out or erase the regrouping from the previous step so that we don't accidentally use that again. So 4 times 9 is 36. I'm regrouping a 3. And then 4 times 3 would be 12, but then I'm going to add the 3 to that and get 15. And there's no place to regroup that, so I just go ahead and write both of those digits down. So I do still have a little bit of addition to do here, but I'm just going to go ahead and add these together. So 5 plus 0 is 5. 9 plus 6 is 15. I'm going to write a 5 and regroup a 1. And then 5 plus 1 is 6, plus the regrouped 1 is 7. And then finally, there's just a 1 here. So I get the same answer I did with the other methods, 1,755. For 256 times 14, we would list the longer number of 256 first. And so I'm going to start by multiplying the 4 times every digit in 256. So 4 times 6, 4 times 5, and 4 times 2. 4 times 6 is going to be 24. So I'm going to write a 4 and regroup a 2. Then 4 times 5 is 20. Plus the 2 would be 22. So I'm going to regroup of 2 and also write a 2. And then finally, 4 times 2 is 8. Plus the 2 that I regrouped is 10. So for that step where I multiplied 4 times everything, I am getting 1,024. All right, so then I'm going to go ahead and move on to the next step. So I'm going to either erase or cross out my regrouping steps from the previous steps so that I don't accidentally use them again. And then since the 1, that's what I'm going to use next, is 1 times every digit in that first number. Since that 1 is technically in the tens place, I'm going to need a placeholder 0. So I'm going to put a 0 here and then start multiplying that 1. So 1 times 6 is 6. 1 times 5 is 5. 1 times 2 is 2. And then my last thing here is just to add these up. So 4 plus 0 is 4. 2 plus 6 is 8. 0 plus 5 is 5. 1 plus 2 is 3. And then let's take a look at our last example. This one, they're both 3 digits. So that means that it doesn't matter what order I write these in. So I'm just going to choose to do it in the same order it's listed and write the 705 first. So I am going to move through this right to left, starting with the 6, multiplying that by all 3 digits in 705. Once I'm done with the 6, then I will move to the 9 and multiply that by all 3 digits in 705. And then finally, I'll move to the leftmost one, the 3, and multiply that by all 3 digits in 705. So I'm doing the expansion. I'm expanding each of these numbers, but I'm doing that in my head. So I'm going to start with the 6 times 5. 6 times 5 is 30. So I'm going to regroup a 3. And then I'm going to write what remains, which is 0. Then I'm going to do 6 times 0, which anything times 0 is 0. But then I'm going to add the regrouped 3 to that. So 0 plus 3 will give me 3. And then finally, 6 times 7 is 42. And there's no place to regroup that, so I'll write both of those digits down. So then I'm going to go ahead and move on to the 9. And I'm going to either erase or cross out my previous regrouping. So since the 9 is in the tens place, that means it's really 90, right? Which means anything that I multiply by 9, I really should be attaching that extra 0. So I'm going to start by putting that placeholder 0 in there, and then multiply all these digits by 9. So 9 times 5 is 45. That means I'm going to regroup a 4, and then write the 5 that remains. Then I'm going to do 9 times 0, which is 0, and add the 4 that I regrouped. So that's going to be a 4. And then finally 9 times 7 is 63, and there's no place to regroup. So I'll write those digits down. And then I'm going to finally move on to that 3. So I'm going to cross out or erase my previous regrouping so I don't get confused. This time I'm multiplying all of my digits in 705 times this 3. That 3 is technically in the hundreds place, so that means that I'm technically multiplying by 300, not by 3. So the shortcut for that is I would just attach 2 zeros. So this time I need 2 placeholder zeros. And if I were multiplying by a 4-digit number, by the time I get to that 4th digit, I'd attach 3 placeholder zeros, and you just continue with that. So here I'm going to do 3 times 5, which is 15. So I'm going to regroup a 1 and write a 5 that remains. Then 3 times 0 is 0, plus the 1 I regrouped is 1. And then finally, 3 times 7 is 21. And I'll write those digits down. And then finally, I'm just going to add all of this up. So starting with my ones place, 0 plus 0 plus 0 would just be 0. 3 plus 5 plus 0 in my tens place is 8. 2 plus 4 plus 5 is 11. So I'm going to regroup a 1 there. And then 4 plus 3 plus 1 plus the regrouped 1 is going to give me 9. 6 plus 1 is 7. And then just a 2 in that last spot. So this is 279,180.